Okay. So today we're working with 2.1, which is getting with our setting up our definitions and working with our properties of integers. So first and foremost, we're getting some definitions down for ourselves and some preliminary work that we're going to be seeing and types of ways we're going to be working with integers right off the bat. So starting with our core definition of an integer, it's going to carry through for the rest of this quarter and through all of your future math classes that you're going to be taking. So an integer is a number that does not contain fractions or decimals. Now, this does mean that an integer can be a positive or a negative, but again, no fractions, no decimals. We really like integers because they're really nice numbers to work with over anything else. Okay? So then within that, we have this idea of opposites or negatives of a whole number. So our core definition, for every whole number a, there is a unique number negative a called the opposite of or negative a, such that a plus negative a is equal to 0. Essentially meaning that for every number that I have, I'm going to have the exact same thing in the opposite sign. So for every positive number, I've got the same thing as a negative, and vice versa. If we're to do this on a number line, the negative is reflected on the other side of 0, which we'll take a quick look at that here. I'll draw one of those in. And again, the nice part about number lines with these, and I think it's just really nice to see them, number line is a great visual for this section, I think, especially when working with the idea of adding negatives, adding, subtracting a negative, that idea of it. So if we're making a number line, I'm just going to draw one out here. We have 0. So we'll go 1, 2, 3, 1, 2, 3. So we have a number line that's showing up here. So we're going with the number lines. We're going by ones. So we've got a positive 4, negative 4. So if we're counting, we've got 1, 2, 3, and so on. Oops. And then we would have negative 1, 2, 3, and so on the other side. So for every a value that I select, so let's say I've got some value right here that we're titling a, then I have the exact opposite or the negative version of that, the exact same spot on the other side of my 0. So again, the idea of if I have a positive integer, I have the exact same thing as its opposite as a negative integer. Yeah? So it's kind of a nice visual of having of seeing negatives and opposites with a number line. And again, if you need reference and make number lines for yourself throughout this section, I think it's very helpful, especially when working with adding and subtracting positive and negative amounts from one another and double signs showing up. So coming back to so we have here, so that's our idea with a number line. So on a number line that we have here, you kind of went through an example of this, 5 and negative 5. We use just a random value a and a random value negative a, but you can work with it either way. So we have, this is kind of the subtle parts, I think, and the little bit picky parts with math and the English language as well, pronunciation of this. So we have this negative sign and a 5, and you can either pronounce it as negative 5 or the opposite of 5. Both ways work. Does not really matter which one or which method you want to go with. Negative 5 is the more common one, but you can and will see it occasionally written as the opposite of 5 from time to time. Okay. When you are setting up a number line for yourself, these are things that you absolutely must do, because I think there's a few problems that might have you working with this. There's a few problems that might have you draw out a number line. So if you're making one for yourself, I would definitely say these are things that are worth noting here. So when setting up a number line, define where 0 is and define the values in the positive to the right of 0 and negative to the left of 0. So I'm going to go back to our other screen just to show you guys an example of what I mean with this. So we're just going to clear all this out. So again, if you're going to make your own number line from scratch, got a line set up there, define 0 in the middle. Always, always, always do that. If you don't define that 0, then we don't know what we're referencing. I like also doing, okay, so this is going to be my positive direction, that's my negative direction. A lot of people do not define the directions for themselves, and then I get instances where if you go to the right, you get positive numbers, and if you go to the left, you get positive numbers, and we can't have that. So once you've done that, you can set up a couple lines for yourself there, and then define what each of these things represents. Am I counting by ones? Am I counting by twos, threes, fours, whatever it may be? So if I'm going to count by, let's say I'm going by ones, so I'm going to have essentially, where's my spotlight here? So if I would have, I could write this out as 1, 2, 3, 4, 5, and then -1, -2, -3, -4. So we have each of our marks represented. I know the scaling on them. We're good to go there. Your other option that you have, and maybe you've noticed this as I was writing it, it got kind of crammed in here with being able to fit everything in. And we might have a little bit of messy writing come up, which does happen. So you also have the option, instead of writing it out as each individual spot, you can just write it out on a couple of them. So maybe you want to, instead of having on every one, you want to say, okay, well, I've got 1, 2, 3, 4, and there's 5. If I'm grading this, I can see very easily that you have scaled this by ones, and that's fine. In the opposite direction, let's say you want to go -2, and -3, and then -4. I can also see that you've scaled it by ones in the negative direction as well, which is perfectly acceptable. So you have either of those two options for yourself if you are setting up a number line. But again, make sure you've defined 0, and you've defined the positive direction, you've defined the negative direction. Okay. So we'll jump back to our notes again. I just wanted to show this example of making a number line because it's worth seeing at least once. So now we get into some of the more tricky parts. And I think tricky is only because of the wording and how we think on it. So we have opposites of opposites, which again, I think it sounds a lot more complicated than anything else, but we do want to go through it because negatives and positives interacting is not going away. It can trip people up. So our main definition of opposites of an opposites. So we're going to let A be a value. Then the opposite of A is A. Again, when you're reading through this, if you're hearing that for the first time, you're going, okay, hold on, that doesn't make much sense. It's kind of complicated to listen to. Yeah, it absolutely is. So again, the opposite of A is A. So it can also be stated in the more common phrase as the negative of a negative A, or negative of negative A is A, which again, a little bit nicer, but can still become a mess. So algebraically, how do we write that out? Well, I have the negative A. We have a negative times a negative, and that's going to result in us having a positive answer at the very end. So again, sounds a lot more complicated, I think, when it's written out. But algebraically, it's just having a negative of a negative and then get a positive answer showing out from there. Okay. Then we have our definitions of positive and negative integers. Again, this is, I think, fairly straightforward stuff that we've seen or is fairly common sense. We've gone through these, but we're going through them all the same just because they're worth seeing. So our definition of a positive and negative integer. So an integer is positive if it lies to the right of 0, or also known as the origin, on a number line. This means A is positive if and only if A is greater than 0. Vice versa for negatives. So it's only a positive number if it is greater than 0. It is only a negative number if it is less than 0. And that includes, even if it's 0.000000001, that is still bigger than 0. It means it's still a positive number. Another kind of fun fact that comes out of this, 0 is neither positive or negative. It's nothing. So it's always just going to be its own individual negative on there, or just or not the negative, own individual thing on there. Neither of those. Which is both really cool and kind of weird at the same time. A number not being a positive or negative. Which does bring us then to inequalities, which are, we're going to get to a few more of these and work with more of them a bit later on. I can't remember if it's in Math 70 or 72. I know we get to them in 72, but we'll see if we get to them in 70. Memory off the top of my head is not helping me on that front. So when we're working with and we're reading inequalities, we always read them left to right. So our first one that we have here denotes that something is greater than something else. Our second one denotes something is less than something else. So I've included in here some kind of silly tricks that maybe you remember, you have heard or otherwise, to remember, all right, well, which one denotes what? How do I tell what sign means what? So there's the alligator analogy, and I'm sure everyone has probably heard this or at some point in time maybe heard it referenced. But the idea is the inequality is an alligator mouth. It always wants to eat the biggest thing possible. The open part aims to the larger value. So if you're trying to going through, okay, this thing is greater than that thing, think of it as an alligator jaw, and it's trying to eat the biggest thing possible. The other one that I've heard, it's less common, but it's one just noting it either way, whatever is going to help you remember it, is the idea of a bird beak. The pointed end of the inequality is a beak of a bird, and bird eats small bugs. So the point is always aiming to the smaller value. Whichever one you want to use. I heard the bird beak one, and I thought, oh, that's kind of interesting to kind of reverse it, another way of thinking on it. So if and when you are working with inequalities in the future, two ways you could go about remembering or how to work with those. Either one that you would like to use. So our next part, as we're working with values on a number line, if we're comparing two values on a number line, A and B is farther to the right than A, we denote this as A is less than B. And we're going to use what's referred to as inequality notation. So we're not just going to write it out as A is less than B. We're going to write it out actually using these symbols that we have and that we just learned here. So I'll go through and I'll demonstrate this with a couple lines here, a couple examples. I think it's worth seeing the different ways of how we could write this out. So we have, in this instance, we have, again, A is less than B. Using the inequality notation, we're going to write this A less than B. Now the nice part, but at the same time subtly very restrictive and very demanding part, is we can rewrite this in alternate format to mean the exact same thing. So our first one has it written as A is less than B. Well, we could also say that B is greater than A. And using the inequality notation, we have it written out as B greater than A. Notice that, again, if we're using our analogies that we have here, using the alligator one, alligators still going after and eating the bigger number here, which is B. Same thing that we have here, except it's just written in a different ordering is all. So two ways of writing the exact same thing. But again, the ordering and the way that we have our inequality in the middle absolutely matters. Have to make sure we've made it clear for ourselves which value, A or B, is larger, and make sure that if we're going to flip this thing around, the inequality is still facing the correct value that we need it to. Yeah? So I'm going to jump us over to the blackboard just again to give a visual example of what this might look like. So we'll jump over there. And we'll just make a new one here, again, for the sake of seeing the process of making a new number line and how we go through that. So again, I'm going to set the number line. I'm setting up 0. I have a positive direction, and I have my negative direction. Okay. Set that there a bit later. So I'm going to define then, I've got 1, 2, 3, 4, 5. And I'm going to scale this by, for the sake of doing something different, I'm going to scale this by 2s. So I'm going to say 2, 4, 6, 8, 10. 10 there. For the sake of making that easier, we'll go 2, 4, 6, 8. So I'm going to do the same thing in the opposite direction. So I'm going by 2's on my number line. I've defined 0, I've defined positive and negative, and the scaling on it, so we're good there. Now our example said, when comparing two values on the same number line, A and B is farther to the right than A, we denote it as A less than B. So I'm just going to draw in our couple examples here that we have with this. We don't know what the exact values are. We'll just write it in here. So let's say we have our value right over here, and this is B. And a little bit to the left of that, we've got our value over here, which is A. So just as the problem says, we have B is farther to the right than A. So how could we denote this? Okay, we went through an example of it, but again, I want to go through the process. So B is farther to the right than A. So we have either option of ways we want to write this out. We can say A is less than B. Because again, on the number line, it's a great visual of seeing that. Or B is greater than A. We have our answer there. Make this A a bit nicer. There we go. So when it comes to it on the test or on the homework, either way that you want to write these out or write this out for yourself is correct. I do think, and this is one of the other things I'm trying to go through and make sure is going to happen or be correct on the test, because either of these are correct, WAMAP sometimes gets a bit picky with saying, oh, you ordered it this way, it needs to be it should be reversed to get the right answer, when that's not necessarily the case. Both of these things mean the exact same thing. Okay. So I think when we're going through these and they're saying, determine whether something is greater than or less than, again, setting up this number line for yourself, I think is very helpful to make that happen. It's a great visual of seeing what things are and aren't greater than one another. It's very helpful in that regard. Okay. So we'll jump back to our notes because we have one last thing that we need to touch base on, which is the absolute value. Scroll down here. Okay. So the absolute value, and we're going to go through some visuals with this. I think it's very helpful. Because the absolute value is not inherently the most obvious thing to work with. So our definition of the absolute value. The absolute value of a value is defined as its distance from the origin, also known as 0. So again, a number line is very helpful when we're looking at and visualizing and getting an idea for what an absolute value actually looks like. So the absolute value of a number will always yield a positive value when there is no such because there's no such thing as a negative distance. Again, our definition, the absolute value of a value is defined as its distance from the origin, its distance from 0. And we do not have a realistic instance anywhere in life showing up where I have what's the distance from this location to that location, and we have a negative number showing up. We always have positive distances. So because our definition is working with a distance, our answer, the numerical value of the absolute value of something, always has to be a positive. And we'll go through and we'll take a look at an example of each of these here. So if we're going through a quick run through of how to work with these, okay, so the absolute value of negative 16. Well, again, the absolute value is defined as the distance from the origin. So how far away from 0 is negative 16? Well, it's 16 spaces, which means I'm just going to take this number and make it positive. We have the absolute value of 2. Okay, so I just want the positive answer from here. So the absolute value of 2 is just going to be 2. And then this is kind of one of the weirder ones that show up, and we start having to use PEMDAS with this. So I'm going to hold off on going through this one for now. Let you guys think on this for a little bit. We'll take a look at the visuals of the first two here, and then we'll come back to this one, because this is an interesting one. And we'll go through an example I'll make one up here because I think it's worth seeing, of working with PEMDAS and the absolute value, because it is one of the subtle parts that shows up with these, and it's really nice to have that nailed down as well. So I'm going to jump to our whiteboard, and we'll go through a visual of each of these two examples because it's very much worth seeing to go alongside our definition. Okay. Okay, so we're just told we're working with our first example that we have. So example 1, we're working with the absolute value of negative 16. And let's assume we hadn't done that other part on the other page, and we're trying to figure out what that's going to be using a visual. So if we have our number lines set up, I'm going by 4s for this. I'm going to have set up like this. Again, the preliminary work, just getting this thing set up for ourselves. So we're told to find the absolute value of negative 16. Okay, well, where is this thing on our number line? So let's mark this over here. So we're starting with negative 16. And again, our definition of the absolute value is defined as its distance from the origin. So how far away from here to here is that? Well, it's going to be 16 units. And that is all that the absolute value is asking for. So the absolute value of negative 16, again, it's just going to be that. Oops. Use blue here to keep the numbers similar. So the absolute value of negative 16 is just going to be that positive 16. It's that distance. Yeah? So looking at again, that second example, I'm going to use the same number. We'll use a different number line, actually. Just move this up a bit. So I'm looking for the absolute value of 2. Go there. Make this a better 2. There we go. So again, we're setting up our number line. You can just get the visual for this. You guys do not need to do this every time. I just want this to be visual for how and why we're getting positives showing up with this. So the absolute value of 2. So we have 2 right here. And again, we're looking for the distance from 2 to 0. So what is this distance that I have here? It's going to be 2 units, which tells me what is the absolute value of 2? This is going to be 2. Okay. Now our last one that we had, kind of a weird one. So our third example that we had the absolute value of negative 9. Now we're going to see things like this showing up on the homework. This is something that could be showing up on the test. We'll go through something that it's a little bit more elaborate, but showing up on the test. Let's work through this thing algebraically first. So if we're trying to determine this value, you can also think of this as we are evaluating what we're working with here. And when I hear the word evaluate, the same thing as hearing the word simplify. And we should have a buzzword popping into our head. I'll give you guys a quick second to think about what that buzzword should be. I hear simplify or evaluate. So if we're thinking on that, if we hear out of those words, the first thing that should be popping into our head, PEMDAS, or order of operations. It's going to dictate exactly how we're going to go through and solve this thing. So again, we'll go through and use PEMDAS with this. Now, if we're working with PEMDAS, first things first, we're looking at parentheses. And absolute values are considered to be parentheses. The subtle part about them, When we go inside the set of parentheses, again, we need to restart PEMDAS all over again. So we simplify everything inside the absolute value sign, and then we apply the property of absolute value where we make it a positive at the very end. So I'm looking inside the absolute value here first, following the parentheses part. So I have a negative, negative 9. A negative and a negative make a positive, which means I have the absolute value of 9 showing up now. It's a bit more clearly defined. There we go. So now I'm looking to my order of operations saying, okay, so I still have parentheses, technically an absolute value sign. Can I simplify anything else inside the absolute values? And I just have the number 9 in there. So I cannot simplify anything else inside that. Now that I just have a number in there, I can apply the property that absolute value gives, which is, what's the absolute value of 9? It's just going to be 9. And I'm done with my parentheses. Do I have any exponents showing up at all? I'll use a lighter blue here. I do not, so I'm done with that. I don't have any multiplication or division. I don't have addition, subtraction. I'm done. So we get our answer here. And if you wanted to, again, we can make the visual of this thing. So right when we get to this step here, you could rewrite this just as we did our problems here if you wanted to make that visual for yourself. You don't have to, but it's a nice way of at least seeing where some of these things show up. Okay. So that's how we kind of our basic use of the absolute value sign that we have in there. I am going to go through, this isn't an example that is listed in any of the lecture notes, but I do want to at least go through one of these now. We are going to see more of these later on, but I think it's worth seeing sooner rather than later. So this is the last thing we're going to do for today, and then we'll move on to any questions you guys have about anything. So again, not in the notes, just separating this out for ourselves. But I do want to go through a slightly more in-depth example of using the absolute values in the simplification process, because I think it's worth seeing and the subtle ways that we need to use it. So I'm making one up here. So simplify, again, we're using PEMDAS for this. And let's go with this one that we have here. Depending on how long this takes, we might go through a second one just because it's worth seeing. Okay, so we're told to simplify, and we're working with 7 plus 3 times the absolute value of 4 minus 9. I'm going to make this 9 a bit more clear that it's a 9. There we go, because my 4s and 9s tend to kind of look a bit similar there. Okay, simplify. That's your buzzword, PEMDAS. That's what we're going to be using here. So again, if you need to do this for yourself, I really like doing it because it keeps me organized. So simplify. First things first, I'm working with parentheses. I'm looking at what can I do inside parentheses first. So all I'm doing is looking inside of the absolute value sign here, because again, we treat the absolute value sign as if it were a set of parentheses. So I have stuff that's going on in there. I don't have parentheses inside of it. I don't have exponents inside of it. I don't have multiplication or division inside of it. But I do have addition, subtraction. So I'm working with that. So in my next line of work, that is all that I'm doing and changing with it. So 4 minus 9 is going to give me negative 5. And now I'm looking at this and saying, okay, well, do I have anything else that I can do inside my set of parentheses at all? And inside, I just have the number negative 5. So no, I cannot simplify the number negative 5 anymore. So I just have a value left over. And now is where we are going to use the property of the absolute value. So what is the absolute value of negative 5? it's going to be a positive 5. So I'm now going to apply that to our number there. So I'm getting 7 plus 3, and these things are still multiplying. So I need to keep that multiplied out, but now instead of multiplying by the absolute value of negative 5, I'm multiplying 3 times positive 5. Again, by our definition from our notes, the absolute value of a number will always yield a positive value. And again, the subtle wording, the absolute value of a number. We cannot apply the absolute value here. We can only apply it where I have just a number. It's a single value in there. It's the only times that I can do that. So following our checklist off to the side, I don't have anything more I can do inside a set of parentheses. I don't have any more exponents showing up. I do have multiplication or division. So I'm going to be multiplying these two together. Move us up here a little bit because I'm running out of space. So 3 times 5, it's going to give me 15. I don't have any more multiplication or division going on, but I do have addition and subtraction. Getting 22. I have nothing else that I can simplify on that front. We have a final answer there. Okay. So again, when you're going through the simplification process and you have an absolute value sign showing up in there, do not rush your process. The really nice part about the absolute value sign, when we get it to the form or form like we have right here, is that great. All we're going to do is we're going to make that thing positive. Not really a whole lot to it beyond that. You cannot apply that property anywhere sooner until we have only a single number left over inside. If we do it any time earlier, like we do it in our first step, and say, well, this thing's positive, great, but this thing is negative, so I'm going to change this minus sign to be a positive value. You can't do that. We can only apply the absolute value to a single number. So it has to be fully simplified inside there before we do that. And again, this isn't in the actual notes that we have. I just wanted to go through this to give you guys an early preview of when we are working through this with other problems where we have to simplify. But beyond that, that is everything for 2.1. I'm going to end the recording here, and then if you guys have any questions, we'll go through those. And if not, then I will see you guys at the office hour at 1 p.m. this afternoon.